Hello, hello. Welcome everyone. So today is Sunday, our usual LeetCode / system design time. I hope you can hear me well. So the agenda for today is a bit changed. So first we're gonna do 3 questions into LeetCode. So 3 LeetCode questions. Then we are moving to Q&A session. I have 2 interesting questions for today. Yep. Interesting to discuss them. And let me also check whether everything works as expected. Seems like it. Good. So yeah, today's agenda is a bit different. First we're doing LeetCode, then we're doing Q&A, then we are doing load testing for our system design solution for monotonic ID generator, or in other words, Scalable AutoIncrement ID generator. And then we will go through this list of interview questions that are usually asked in the interview for .NET position or for backend position in outsourced companies. That pretty much all of these questions were asked me once or a couple of times in my previous interviews. Yeah, that's it. We are in the office. Let's slowly start, I think. Yeah, let's slowly start. So our first question, we are moving through the LeetCode 75 questionnaire, I would say. Problemnaire, I don't know. And our question for today is binary tree right side. So what does it mean? Given the root of the binary tree, imagine yourself standing to the right side of it. Return the values of the nodes that you can see ordered from the top to bottom. So in this case, we see that 2 and 5 are not seen if we are looking from the right direction. And in this case, we see that first and third node, you can see them. Second node, you cannot. And since there is nothing below the third node, we should show the left nodes that are on the left subtree in this case. How we actually can implement this? So let's think about it. So this is the binary tree, which means that most probably we're gonna use recursion. But how the recursive calls might help us in a way to detect that, this case is not that complicated. In this case, what we can conclude from this case, that actually, let me show you why you're not opening, please. Okay, sleep until, let's do it in the old way. Yes, I can write on it. Good, this is what I needed. So in this case, when we spawn on this node, we can create some recursive function, right? Function, whatever. And then this function would accept node, and we always call this function recursively, and we always call it for the right node only. And in this case, we just keep adding it to the list. We started from this node, we go here, we count this node, we add in also this node, and when it's nothing left, here's null, right? We just don't do anything else. How come I can... Where is the boundary of the... Okay, and this would be it, but unfortunately we have this case, which is quite more tricky. My notifications just don't work. Like, what the hell is this? Yes, this is what I wanted. In this case, if we start just from this node and we go only to the right, we would get only 1 and 3, but the actual answer, as you can see, should be 1, 3. What? Yeah, it should be 1, 3, 4, and 5. So 4th node and 5th node should be included. But if we just go to the right side, we will never reach these guys. So it turns out that we actually should traverse the whole tree to be able to get the nodes we can see. What is the typical is that we can, for example, first try to traverse the right subtree, because these nodes will be overlapping the ones that we face on the left. So let's say we have like something like this, and here we have so here we have, let's say, I don't know, 6, this guy is 7, whatever. So this 6 should cancel both of these because it's the rightmost. So how we can implement our solution is we're going always to the right subtree, and if there is node, we just add it to response. But we also, after traversing the right subtree, we are going to the left subtree as well. And in this left subtree, we're just checking whether on this level we already have some node. Because if we are at this point, we added 1 and 3. So 1 on the level 1 and 3 on the level 2. This is the level, these are the nodes. In case we then traverse the node 2, we see that on the level 1, on the level 2, these are the levels. On the level 2, we already have the node 3, which means we shouldn't add 2. But then we go to the 4, and 4th node on the level 3, we don't have any node on the level 3. It means we are adding this node to our list. And then we are adding 5 as well, because there is no node yet inserted on the first level. This is going to be the solution. And let me implement it. So we are given root. Let's create our. So first of all, we should have our response should be in array. So response should be array. Also, we're gonna have some map to remember that level-wise whether there is node for such level or not. So there's gonna be some map equals new map. Yeah. And then we're defining our function traverse or DFS, whatever. There's gonna be node and level. If there is no node, we just return nothing. A function is gonna return actually nothing. What we need from this function is to populate the array. And now what is happening here? We are checking if map, or let's not call it map, let's call it, I don't know, levels map. If levels map has already node for the level, or this can be actually a set. Yeah, this can be actually a set. If it has node on the level, so if level is done, so this level is kind of traversed, we do nothing. But if it doesn't have level, we are exactly adding the level to the hash set and adding the value of the node to the response. Yes, and then we just recursively calling this guy for the right node. It is very important first to go to the right, because otherwise if we first go to the left, we are solving exactly the same problem but for the left side view. This is going to be level plus 1. This is going to be left level plus 1. Yes. And now what we are supposed to do is to call this function traverse root for the level 1. This is the first level. And then just return resp, which is our response. I would say this guy should work. Let's check it out. Runtime error, of course, right side view is not defined. What do you mean? Ah, okay, I understand what happened. Casing. Oh, sorry. Okay guys, and this is exactly the point when we should actually stop. Let me just submit and prove to you that it actually works. Yes, 0 milliseconds, and time and space complexity we're gonna solve to be done, and space to be done, because I'm gonna get the delivery. I'm software engineer at Microsoft and I'm hungry as well, you know. So yeah, see you in 2 minutes. We will continue in 2 minutes. Good, this is what I would leave, and yeah, see you in 2 minutes. Okay guys, I'm back. So now we're gonna continuously finish my stream without any disruption, any interrupt. So yeah, what we did before is this is the implementation for this problem. And can it be done better? Actually, it can. So one improvement that you might think of, I will show you a bit later. Let's first finish with the time and space complexity. So regarding the time complexity, we are traversing the tree completely. So revisiting every single node, which means that it is ON. There is no any optimization. And also on top of that, what is the space complexity is of height, whereas height is the height of the tree. It can be n in case the tree is completely unbalanced and it represents linked list pretty much. Imagine 2 and 5 do not exist. 1, 3, 4 as a 3, it is actually a n. So height will be 3, n will be 3. Yes, and actually you might say that it is 2 times height because we have recursive function which has height number of calls, and also we have this set which also contains the number of levels, and number of levels is exactly the height, so it's 2 times height, but since it's big O, we don't care about this constant. Now what would be the optimization? We actually can remove these levels completely, and instead of checking this guy, we might check whether response length, since our response is resizable, it is a dynamic array in JS, we can say that that if our response length, wait a bit, if it is less than our current level, it means this level is not added yet to the response. So we are adding it, and that's basically it, I think. Let me rerun. Yeah, great success. Good. Good. Let me test that chat works. Chat works. Good. Okay, let's move on to the next question called maximum level sum of a binary tree. So, what is this problem about? We have given a root of a binary tree, the level of its root is 1, the level of its children is 2, and so on. Okay, so level starts from 1, not from 0, like an array, for example. Return the smallest level x such that the sum of all values of nodes at level x is maximal. Sum of all values of nodes at level is maximal. Okay. So I think I understood this problem. Yeah, we have level 1, which only has node 1. We have level 2, which has nodes 7 and 0, and level 3, which has 7 and minus 1. We are collecting these sums and returning the level, right? Smallest level. Yeah. So basically the first level, right? It should be such that sum of all the values of nodes at level x is maximal. So I think the approach here would be pretty much similar like in the previous one. We need, not approach, but the problem definition, because we need to process our tree level by level, which kind of can complicate things in case we are talking about recursion, and we are talking about recursive function in this case. So one of the ways how I would implement it, like initially, but we're gonna get another solution as well. So there is recursive solution and iterative solution. Basically, we can say that there is always iterative solution. We can emulate stack by using stack data structure instead of your native thread stack, which will increase your space capacity from, I don't know what is the stack size of the thread, but you will increase it to basically the size of your RAM. Okay, anyway, what is the approach for this problem? Let me remove everything unnecessary. What is the approach? The first approach might be that we are basically traversing the whole tree, and since it's sum, we don't really care the ordering of the elements we're gonna sum up. We start from this node, and we have some kind of memory. Let's say it's map or like whatever you like. I would use map, and we have like level 1, and it's sum, level 2, and it's sum, and so on. And every time we are moving kind of downstairs to the tree, so we're starting from this node, we go, let's say here, we're traversing here, we increase the level number. So this level would be 1, this level would be 3, and so on. We're just summing up per level, and then we just return the maximum level so far. So I would say this would be the this would be the solution. Then we just would traverse them up and get the maximum level. Let's basically implement it. So first solution will be DFS. We're gonna just traverse node, and we have level. Sorry. So what else do we need? We have maximum. We're gonna we need first of all that level map, new map, exactly, default check over here. Also, this function does not return anything. We're just gonna traverse the whole tree, and that's it. So what we do, we have our level map, and we are setting every time adding up the sum to our current level, which is gonna be like this. So we're getting level map, get level. If it doesn't exist, we're returning 0 plus, not plus 1, but plus not value. Exactly. All right. And then we recursively calling DFS for node left and level plus 1, and DFS for node right, level plus 1. Does not matter which order actually, because in the end we're gonna visit everything, and the order of the summed values, it doesn't matter. So once we call this function DFS for the root and level, we start from first level, right? Level of its root is 1, yeah. Now what we're gonna do, we're gonna define max level, let's start from 1, and max sum, which we are setting the minimum possible value, so min safe integer. Exactly. And now what we're gonna do, we're gonna traverse the level sum of our level map, which we already accumulated. And what we're gonna do, there's gonna be some local sum. No, we have sum already calculated. So if our sum is more than max sum, which in the first case it will be the true, we are setting max sum to sum and max level to the level. And then we basically return max level, because this is what problem asks us to return. Let's try to run this guy. Test passed. Let's see. Good. We're good to go. It beats 80% of everything, and now let me show you the BFS solution, because this is DFS. Yeah, we can actually convert it to iterative solution by just emulating stack, but there is BFS solution which is natively kind of come up to this problem. And let me show you on this solution as well. Oh, sorry. Yeah, let me remove this bullshit completely. So, what is BFS? Unfortunately, since BFS is using queue and there is no native implementation of the queue in the JavaScript, in JavaScript it's implemented using the array and shift function, which basically removes the first element and shifts whole array to the start. The complexity is not O1 but O(n), unfortunately, so we can kind of assume that we can implement the queue, like we really can do it using like some circular array or maybe linked list, whatever. Anyway, how BFS works, that we are going to traverse tree level by level naturally by the nature of BFS. So how BFS would work, let me explore. So basically we are starting from this node and we have some queue. So we have some queue of nodes we need to explore. We're starting our function and we put first node straight away to the queue. Once we add it to the queue, we are traversing and processing the queue. And we are explored two nodes here and there. We just add them both to the queue. And this guy will be out. This is our queue right now. We go to 7th, we explore it. We add basically we add 7 and minus 8. This guy goes out. We explored 0. 0 has two nulls, so we don't add it to the queue. Now we have Q7 and 8. Again, these two have nulls, and we explore them. We are done. Typical BFS. And the thing is that every time we are iterating over our queue, it means actually that we can basically not remember the level sum, because our queue elements, they are exactly the level since the BFS nature, because it goes like gradually exploring the tree or the graph. Tree is kind of subset of graph, right? So let me implement this solution as well, the BFS one. How do we start? We have our queue. Hello, Dima Olex. Hello. Eventually, first comment. I don't know why traffic is so low. Usually we have like 6, 7, 8 people watching simultaneously. Now I have like 3, 4 people. I don't understand what happened. Maybe I got blacklisted or hiddenly blocked in my YouTube or in my Twitch or in both, or maybe it's Sunday evening. I don't really know, but let's keep going. So as we explored and explained before, we're just adding our queue and we're gonna traverse while our queue our queue length is not equal to 0, which would mean we processed everything. Now in our queue we're going sum equals 0, and let's define also queue length. This is the interesting case why we are doing it. I will explain you later. Now we are just traversing through the whole items in our queue. And what we are doing inside inside the loop here, we're basically adding. First, we are removing item from the queue. We are popping it. Now, what we're gonna do is sum plus minus node value, because we know that in this iteration, in this for loop, we're gonna have nodes from the same level. This is kind of proven from the nature of the BFS, right? And now what we are doing, we are checking if node left exists. We are adding it to the queue. Same thing happens with the node right. Exactly. And after for loop, what we'll do, we are checking whether our sum is more than our maximum sum. Let's define our maximum sum as well, which is going to be exactly like previous solution, minimum safe integer. And if our sum is more than max sum, right, then we are assigning max sum to sum. But what the question is asking us about, it is asking about the level. So we need to have also max level equals to some default one. Max level equals to, and also we should track the level, right? Let's define level above. It's current level, and max level is set to current level. Exactly. And after every such time, we are increasing our level, because whenever we kind of processed whole queue in our BFS, we are kind of done. Level is increased, that's it. After that, we're just returning. I need to move this guy a bit. Yeah, this way you should see everything. We're returning max level, right? Well, yeah, let's see whether it works. It should actually. Yes, it worked. Let's submit. Yes, but the performance is so slow due to the fact that we are shifting this array, because it's implemented via arrays. And I'm now thinking maybe we can actually do even pop, because since we don't care about the ordering, maybe, no, we actually cannot. Yes, because we are adding, yeah, this is the problem, we are adding, we cannot use stack in this case. We can reorganize our DFS solution to use stack, but unfortunately this should be using the queue. So yeah, this guy gives us O(n), unfortunately. And overall, the complexity, if we assume that the queue operation takes us of constant time, even if we assume that, we basically traverse all the nodes on the tree, which means the time complexity is of n. Then we are, like in DFS solution, we are also iterating over the loop of the whole levels, but this is all height, right? The space complexity in DFS, it's height, which can be also n if the tree is unbalanced. And and queue can have maximum 2 levels worst case, which is basically, yeah, it's the number of the lowest leaves. So what is the maximum number of leaves the complete binary tree can have? If I'm not mistaken, this is 2 to the power of height, right? Yeah, minus 2 to the power of height minus 1, I guess. Let me actually double check myself even. So let's say we want to know there is some complete tree. Complete tree, it means every single node except the leaf nodes has children. So this is our first level, second level, third level, fourth level. Our height equals to 4. How many nodes do we have here? So we're starting with 1 node on the first level, second level we have 2 nodes, third level would have 2 doubled, which is 4, fourth level would have 4 doubled, which is 8, and so on. 8 doubled equals 16, 16 doubled equals 32, and so on. So basically on first level, this is second level, this is third level, this is fourth level. On the first level we have 16 nodes, and overall in this case we have 1, 2, 3, 4, 5, 6, 7, 8 nodes on the lowest level. So this is basically 16, this is our n, and our children in this case, or leaves, is 8. So this is basically 2 to the power of 4 minus 2 to the power of 3, which is gonna be 16 minus 8 equals 8. Exactly. So this is the formula for the space complexity. Good, good. I think we can move on as well. We have search in binary search tree. Pretty easy topic. This is one of the topics in binary search tree. So before that we had just binary tree, now we have binary search tree. We are given a root of the binary search tree, an integer value, and we should find the node. What is the binary search tree? Binary search tree is the tree that fulfills these constraints or invariants. Let me show you that for every single node in binary search tree, if this node is x, we know that right subtree has values that bigger than x, left subtree has the values that are smaller than x. This is the invariant. And usually binary search tree is the structure that is used for quickly searching some item in ordered collection. So usually when you have some ordered collection, 1, 2, 5, 10, 20, you can find some number or check that this number exists here in log of n instead of O of n. So you're not traversing the whole array in this case if it's sorted. You're just searching in a clever way. So you start from the middle. Then if you understand that you're looking for the 2, you know that number 2 cannot happen on the right part of the array because it's ordered, right? And it's sorted. So you go here and now you're only checking this subarray and you will find your 2. Binary search tree is exactly the same purpose thing. So let's just, quickly implement it. It's not that hard. I would not even use my vMotions stuff here. So hope you, yeah, good. So what we are doing, if there is no root, we return null, because if element is not found, we return null. Now, exactly what is coming from the nature of the binary search tree, if the value is less than our current node, we return whatever we can find in the left subtree. If it's bigger, well, bigger root val, then we're returning exactly the same but on the right subtree. And only in case it is exactly equal to root value, we found our node, we should return root. As simple as that. Good. Now we are done with our LeetCode questions. So far we actually solved pretty decent amount of problems. So I'm starting. So we completed array, we completed 2 pointers, we completed sliding window, prefix sum, hash map, set, stack, queue, linked list, binary tree DFS we completed, binary tree BFS we completed, and now we're doing binary search tree, which is pretty cool. It's kind of middle already, right? Not that many left. Yeah, Sunday by Sunday we're gonna finish this list, and after that I don't know. I will start applying to Google. Yeah, I'm joking. I actually already completed this LeetCode list. I think currently I have, I don't even know how many questions I have solved. I think 200 something, right? Yes, 257 questions I solved so far through all my life. Yeah, now I'm doing this top 150. Okay, anyway, good thing that we solved all the LeetCode stuff for today. Now it's exactly time for the Q&A. And I wanted to talk about pretty interesting stuff. What I wanted to talk about is, yeah, I've seen one question on the LinkedIn today. What is harder, backend or frontend? And the guy was pushing a lot on the thought that actually frontend is much harder than backend. And the reasoning was that, yeah, I was implementing some carousel scene for like a couple of days, struggling a lot, blah, blah, blah. But when I needed to implement some backend, I'm doing it in 2 hours because it's like easy peasy. You set up database, write some one endpoint, and you're done. Personally, I got triggered because initially I'm backend guy. I don't say that actually, you know, backend is much harder than frontend or something like that. I would say that it really depends. And that's why. Let me explain. You have your Google, right? And you could type something here, whatever you want. I was searching for keyboards, right? This is already the backend, right? This history is backend feature. Like, it might be front-end feature, like something can be storing it on the front end in some cache cookie, local store, whatever, like local database, whatever. But overall, the Google search is the mainly backend heavy and complex system. Why? Because search engine itself is not the easiest thing to implement, right? It's completely not the easiest thing to implement. And the fact that Google has been serving like billions requests all its lifetime, it's even more harder to implement it from backend standpoint. Let me like Google search requests per second. Really only 100k searches per second. I would assume it's much bigger, to be honest. Only 99, so 100k searches per second. Anyway, it's a pretty big amount still, right? It's not one request like out of your 3 real customers. And here's the thing, that you have your backend, right? And you really can implement like some, I don't know, compute node. You would put some database, whatever, and you might say, I'm done with backend. Frontend is much harder because it's like, you know, you need to implement carousel. It's very hard because, you know, there are 0 libraries for carousel for your frontend, right? So what I can say about this, until your backend is proper one backend, yes, backend is easy. You can just ask your GPT, generate bunch of endpoints, Docker compose up your database, you're done. But what is good backend in a nutshell? Good backend is first of all a reliable system, which means you should handle the situation when your server and your database is down. And this is already a very complicated, kind of fully unsolved problem in the way that you cannot, like there is CAP theorem, right? Once you solve the problem with reliability, you have the problem with consistency. Here you are. And this is when you need to balance, pick up proper value to have good trade-off and to not upset your customers. So first of all, you should create a reliable backend, which, with ChatGPT, one endpoint and one database, you cannot say that it is you know, it is reliable. You would put it in some VPS, this VPS will go down for a whole day and you suck. That's basically it. Now, next point, it should be observable, which means it's not really enough to set up your database and one endpoint. You should also set up some monitoring system, I don't know, some Grafana plus Prometheus at least, which is completely another server with its own problem for reliability. It should, you know, stays up always. This is another problem, it should be observable. And third property, it should be scalable. Yes, my third reasoning was that it should be scalable, because if your backend service is handling 3 your customers per day, well, you can implement it in that way that your server will not handle it, but mostly, you know, it's not a big deal, it's not a problem. But here is the thing, let me Google Instagram requests per second. I want to have some numbers, some statistics. Millions of requests. Yeah, so for millions of requests, for example, this number I'm very surprised, to be honest. I'm very surprised, because I thought Google search handling like maybe billions requests per second, not millions even, but somehow I'm not true. So 100k requests for some backend systems you actually can implement using only one node, and it will basically handle all the load. You need to think about only the reliability, which is still the problem you need to solve, right? So you need to create your backend bullshit that you think you can do in 2 hours in a scalable way. It means when you have spike of requests, or you have like millions of the requests, this is the time when real backend challenge starts. Backend challenge is like, you don't have actual backend challenge pretty much almost always until you have some big load and until you need to have some guarantees over your system. So this is the thing. For frontend, yeah, I'm also mistaken, because yeah, I'm mainly backend guy. I never did some proper frontend, but I had frontend experience before as well. There is some complicated thing for sure. But in general, over the web, frontend doesn't care about concurrency, which backend guy always should take care about. Because, you know, JavaScript is just event loop, one threaded event loop, and you don't really care about concurrency. You know what will happen if I will do, for example, this? Let's say I have some, I don't know if it... So actually in backend languages, you can easily spin 2 independent while loops and they will be working okay. But in JavaScript, if I do this while true, like, okay, while true just empty, okay, so the setup was, I was checking it before, JavaScript, and I'm not sure about all client applications. I think mobile has multi-threading as well. But JavaScript is a web technology. It has one-threaded event loop, which means you never care about concurrency. You know that if you have some array, blah, 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 and you're pushing some elements here, and you're pushing these elements in different async functions that you do not await, you do not care about that. You know, you can have some race conditions, blah, 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 because this is front end, you don't care about this. On the backend, yeah, backend guys do care about concurrency, which is also the problem you have to solve. And you cannot just lock everything usually, right? Because then it's latency and other stuff. But yeah, so this is the thing, that frontend is hard from its own perspective. I agree, it might be hard, but overall, like on low scale, I would say, yeah, frontend is harder than backend until you have real backend challenges. On the higher scale, I would say that frontend is a bit easier, like has a bit easier problems to tackle, especially depending on the interface and usage, because yeah, here we are, like we have some Google search, and you know, you can put, or you can even generate this UI in a matter of hours, let's be honest. In a matter of like, okay, I'm Googling, this UI can be generated in a matter of hours. Like with GPT, easy peasy. But implement the search engine that would work as good as Google search engine. And then we can talk, right? with the scale of 100,000 requests per second. So this is it, yes. These are two different things, but I have also one interesting point about the front end, and I know exactly the industry where front end is 100 times harder than backend. And this industry or like area is not web. This area is game dev. So if you want to implement multiplayer for Battlefield 1, for example, yeah, your front end, which is actually your game, will cost you maybe 1,000 more times more effort than creating backend for this, for this shooter game, whatever. So in game dev, I agree 100%. Front end is much, much, much harder than backend. However, it still has its own complexities for sure. For example, implementing matchmaking is actually not the easiest trivial idea, but even with these problems, front-end is solving much harder problems for game dev. But in web, it really depends. It really depends. Next topic, I raised it lately in my chat because, yeah, I kind of spent some of my time learning the authorization. I think it's pretty much visible if you go in here. My first articles were completely about authentication, internals, how it works in, for example, .NET, some guides, and learning the official protocols, because auth was for me some mysterious shit that I don't know how it works for a very long time. And I'm now preparing the article and pretty much video about this topic. So why JWT auth is bad. What I mean by this is like usual JWT auth, overall JWT is good. It's very good approach for authentication. You don't have sessions, its status is very good. But the way the people recommend implementing authorization, which is usually, let me draw you, which is usually the following. So how do people usually recommend you? You can just Google, I want to implement client-server authorization. How can I do it? What you would see most likely is that guy or like whoever, even I have these articles to be honest, I think I have, yeah. So I have .NET Backend, I have JWT single page application. How can I, implement authentication and authorization there? So usually what guide you would see is that you have your front-end server, you have your browser, right, and you have your backend server, backend. So typically what is happening, user goes to browser, it directs to your front-end server, it loads your CSS, HTML, blah, blah, blah. And since it's single page application, it goes direct XHR request to your backend. And you somehow supposed to implement the authorization here. And how you would usually see people recommending it to be implemented is that you're hosting some login page from your front end. You have your login and password prompt here. And you're sending these guys to the backend. Over the network, no problem with that, right? I'm joking, there is some problem. And your backend validates that this user does really exist in the database, right? Hopefully the guide would mention that you should encrypt at least password, better to hash. I think, yeah, hash, it should not be decrypted. And then if this user exists, like by login and password, backend returns the JWT token back in the response. This is usually the guide which you would see in the, in the typical article about how to implement authorization and why this thing is bad. Unfortunately, we don't have that many people on the stream and I cannot ask directly, but maybe some of you can say me why this approach is bad, why you should not implement authorization like that, and what is the problem here. Most probably, if you don't know what OAuth protocol is about, what is OpenID Connect about, you will not be able to answer this question most probably, but yeah, maybe you would somehow point out some problems, I don't know. Yeah, I actually wouldn't say somebody would point something, but yeah, if you have any concerns about this while I'm speaking, yeah, raise them. I'm interested what you would say. But the general problem, if we go to North Star OAuth RFC, yeah, request for comments. Let's check the most official thing for some protocols. It's RFC, right? This is OAuth 2.0 protocol or framework, whatever. It has 4 main flows, which are, let me show you, which are, where are them? No, security, yeah. Authorization code grant, implicit grant, resource owner, password credentials grant, and client credentials grant. We can straight away say that client credentials grant do not fit us because it's not safe client, it's private kind of client in this case, and you know, user is not involved in this authorization. But what regarding these 3, what typical auth flow means in typical articles is resource owner password credentials grant. If you go here and you check how is this guy implemented, you would see that this is exactly how people are suggesting to do it. So you have resource owner, blah, blah, blah. This is resource owner is basically your user. It uses the client collects login and password. It sends it to authorization servers. Authorization server returns access token, which is JWT, along with some refresh token, maybe. And what is the problem with, you know, with this thing? If you even go and start reading about it in the official documentation for protocol, pointing it again, is suitable in cases where resource owner has trust relation with client. Okay, blah blah. Yeah, is suitable for client scale obtaining. It also migrate existing clients. Okay, do they? Okay, they do not say about problems this guy have. Yeah, so this is the official explanation for this flow, which is, by the way, 99% of authorization guides in internet is exactly about this flow, but they made it even worse because OAuth at least expects you to implement client authorization on top of the user authorization, which is not usually the case. So what is said officially on OAuth documentation? That the resource owner password credentials grant type is often used for legacy or migration reasons. Even more, if you go to some official identity providers like Microsoft Entra, Google Auth, GitHub Auth, whatever, they most probably will not even support password credentials, so you will not be even able to enable it for your application if you want to, you know, if you want to have Google Auth using users' credentials. No, you cannot do it. So yeah, it's legacy and migration reasons. It reduces the overall risk of storing usernames password by the client, but does not eliminate the need to expose highly privileged credentials to the client. So the main problem in our situation that I was explaining here, what is the problem with, you know, general JWT authentication? That client, in this case, sorry, this is our client. Let me even draw it with different things. So this is our client in this case. It gets the user's credentials, the resource owner credentials, and it is bad. This is exactly what OAuth protocol and OpenID Connect on top of it is supposed to prevent from. It has a lot of benefits when you don't need to expose them, but at least one of the benefits is security. It has higher risk than other grant types because it maintains the password anti-pattern. Exactly, this protocol seeks to avoid, exactly. The client could abuse the password, brute force password even, and like, because, you know, why is that possible? Where is this? no, I didn't draw it, so I will draw it explicitly here. Because browser sends XHR requests. So it means the JavaScript prepares request and sends it to backend with login and password. So now your backend is in charge of protecting itself from password brute force, for example, which can happen, and you should implement it yourself. Yeah, it can be exposed. Also, resource owner does not have control over the authorization process. Exactly. Client can obtain access tokens with broader scope than desired. Yes, so even if you log into some client, you don't know how your credentials are processed, you know, as a just user. So yeah, maybe these credentials will go and, I don't know, with some different scope, whatever. Authorization server and client should minimize use of this grant type and utilize other grant types whenever possible. This is pretty much the answer. This is a bit clickbait title, but overall, what my intention was is to warn people that usual JWT-based login plus password implementation for authorization is not recommended for real production scenarios, and it is not recommended by the creator of two widely used protocol creators, which is OpenID Connect and auth. That's it, period. Stop doing it. Yeah, for sure, I can understand if you have some MVP and you don't have real production traffic or you don't care about security, yeah, you can do your JWT authorization as usually. There is no problem in such approach. Or if you, for example, know you're not gonna extend it, you have only web client, you don't want to include later on the external identity providers like Google Auth, GitHub Auth, yeah, you can do it as well. But most of the cases, especially in my experience, all of the projects that were implementing this login password exchange for JWT usually later on were asked to implement some Google identity provider, and this is when you have problem, because you know now you need to implement same OAuth authorization code authorization, but now you need to implement it from your backend to the Google authorization service, for example. So your backend will start acting like client, and Google server's authorization server will act like authorization server. And your client will be just, you know, some custom wheel that you reinvented just. So this basically abstracts the login logic to its own layer provided by Google or other auth provider. Yes, exactly. Typically, the problem is that Frontend, this guy, Frontend server, because it's also server, it serves the CS and HTML and JS and all this bullshit. And backend server, they are two different servers with different domains, and they are two different origins, which also has the problem, and usually, not usually, always, authorization servers, they do not use any fancy clients. So whenever you're implementing authorization server, you don't have client. You can check different implementations, but generally speaking, you don't have client. This authorization server serves login page on its own. You don't have this fancy React SPA for that. You don't have like Next.js, whatever. No, our server serves the login page. Why? Because later on, you want to use form for submitting your login credentials. So in this case, when this is done properly, yes, it's worse from the development maybe approach, because you don't have, you know, your React fancy shit. You need to search HTML from the server, right? But in this case, since you're using forms, you cannot be basically brute force. The probability for that is lowered because you can use anti-forgery token or forgery token, whatever, that is issued each time the login page is loaded to the browser. So instead of XHR, you're using natural HTTP methods to serve the page. This is first layer of protection straight away, just from the fact you don't use external SPA client. Another way of protection, this is completely on the auth server origin or auth server domain origin. which means it has its own cookies. They're isolated, like it can have the best security purposes. And the benefit of auth that later on you can just add on any number of clients, mobile, desktop, web, just in a matter of hours, because you will have exactly the same login page for all of them. The experience will be consistent. You will have single sign-on. You need to add Google provider. You just implement it in one auth server, and it starts working in like mobile, web, desktop, whatever else. So there are a bunch of reasons to actually go and start with auth implementation straight away. There are different approaches for that. For example, there was identity server. I'm talking mostly from .NET perspective, right? So now it's Duo-N, the software. So there was some, bureaucracy stuff. Now it's paid, so you would usually not want to use it, right? Because it's paid, but it's good implementation. It's good implementation, and you don't have to implement much stuff over it. There is another thing called OpenID Dict, which is implementation of OpenID Connect provider. Okay, interesting. Whatever, I mentioned it. I think this is already enough. You can check it, but in this case, you have to implement a lot on your own. However, the overall auth and OpenID Connect framework is there. Is good. Or you can use already made solutions, like you can implement your auth, just log in via Google. In this case, you basically will use Google Auth server, so you will have your auth provider, but you will not have your own login password shit, and it's good. It's good. Usually it's better to serve it to some other provider. If you want your own provider, there is also how it's called, not ClickUp, auth service, not service now. What are different other implementations, I mean? Okay, whatever. There are already SaaS solutions when you just click a couple of buttons and you have your authorization server straight away. You don't need to even care about it. But the easiest way usually is just put your button auth through the Google, and that's it. Okay, we have some comments. So doesn't that also introduce the benefits to have some data located in cloud services so that you can mitigate some issues with legality and reliability? Yeah, exactly. Like privacy, I don't even include. Like usually the startups or services that are just getting built, they don't care about privacy usually at all. Because yeah, let's do MVP, let's do this easiest possible shortcut. And then when they got some investment and start thinking about it, it's a big rewrite happens usually, yes. But from regulation standpoint, it's also better to have auth for sure. For sure. Yeah, privacy is completely different topic. Especially from what I see at Microsoft, we do really care about privacy. Like privacy for Microsoft is on very high level, and it brings a lot of development pain, guys. Privacy is a lot of development pain, believe me. What about startups? What would they use instead of JWT and authentication? About what want to stay within budget? Are our services free or have fees attached with them? So usually you would pay something, yeah, but they also have some free tiers. So for example, I think there is OAuth 0 provider, for example, that one startup that I knew and I was helping with was using. It has free tier as far as I know, but I'm not really, I cannot confirm it. There is also Clerk, I think, or Clerk, whatever. This is also cool stuff for startups. It's a few clicks and it's very, very cool stuff. It's a bunch of features. And as far as I know, up until 10,000 users, it's free as well. So these are the tools I would use for authorization in case I'm startup, but I'm not. I think we are done with the hot topics, you know. And now, what we are going to do, Q&A is done. let's create load tests for our system design. I will recall you guys what we are doing here. So I think I can basically remove this thing completely. So what do we system design here? Now system design starts. Initial idea was to design URL shortener, the basic system design question, right? That is being asked in pretty much a lot of places, especially funks, monks, all this stuff. And we concluded during one of the previous streams that actually one of the best approaches to generate this teeny URL suffix, which should be random and unique, one of the best approaches is incremented unique key. And what I mean here is it should be numeric key. Bunch of advantages. Pretty much we realized that this is the best one. What is the problem with this approach for your URL shortener in scale of billions of requests? Maybe millions, 1 DB can handle. But if we have billions of requests, then I think we cannot serve unique auto-increment key from database anymore. So what I wanted to do, I wanted to design scalable solution for unique random or pseudo-random numbers generator. This is for the cases when single database with single table of primary auto-increment ID is not enough. Or I don't know, single Redis instance with just one key that is auto-incrementing all the time is not enough when you need more instances to handle this. And what actually was the solution that we come up with? There are a bunch of them, but what is the best solution? It's called Snowflake ID generation. This solution is used in a wide range of actual services like Discord. As far as I know, it was initially designed by Twitter, and maybe in Discord it's also used. So this is kind of production proven solution. How it works? They got basically the idea of universal unique identifier, UUID, also known, or GUID, also known, and they are generating it using pure computes. So they don't use any storages, any database at all. How it works, that you have a bunch of load balancers, and you have nodes that can generate the number. And how the generation works, you have 64 bits, which is the size of long type, usually. So you have 64 bits to store the information, 0 or 1. And how it works, that first 41, I guess, bit is reserved for monotonically increasing timestamp with the dimension of second. This guy is reserved for machine ID, and this guy reserved for monotonically increasing sequence number, which we increase monotonically and atomically by using interlocked or specific increment function. We already implement the system. This is the system. We have our identifier endpoint. We are getting milliseconds. We are getting sequence number, machine ID, and we basically generating the identifier by shifting the bits to proper places, and we are serving this identifier. Today I want actually to write some tests for this. So I think I have opened the repo, and we already had load testing on our rate limiter. So I'm gonna just paste this folder completely, and yes, this is basic load testing. We are using case 6 for load testing, which just spins parallel request to our URL, and it's requests per second. So every single second this request is performed, basically. Also, what I want to do, I think we need to dockerize this solution first. So the plan is to put it into Docker container, put some limit to the memory and CPU, and then perform load testing over like a couple of thousands requests, right, and see how it works, whether we have duplicates or not. For the duplicates detection, maybe we can spin Redis instance, for example, and write all our IDs just as the keys, and number of times we put these numbers to, to ensure that we actually don't have any duplicates. This is the way how we're gonna do it. So first of all, let's put it to Docker. I think I already have. Yes, I already have some. Oh, we even have, we have everything we need. Sorry guys, I think I need to have some break also for, I don't know, maybe a couple of minutes. And we're gonna proceed later on. So break 2 minutes again. I will be back. System design of auto scalable auto increment. These are for new guys that will come. Yes, see you in a couple of minutes basically. Okay, streamer is back. So what we have stopped by, previously we were going to Dockerize our scalable auto-increment solution, put it into the containers, and I'm thinking right now that maybe we can even start another solution for the URL shortener that will call our actual Snowflake auto-increment implementation. This is what I'm thinking about right now. But let's first let me turn off the Vim, because I will be doing a lot of Ctrl-C, Ctrl-V, which is not that convenient with the oh shit, I need to ban some guy. Good. This guy is banned. So yeah, let me implement and Dockerize our app. Since I already did it for rate limiter, mostly what I'm gonna do, I just gonna paste Docker files and whatever else I need, and a bit fix it or tweak it. So first of all, the good idea is to put it under the SRC folder, which is mainly the common approach. So your source code should be in SRC. Yes. Idea. So this guy, and this guy. For that I need to close the solution. Yes, we are moving to SRC. Exactly. Then we have load tests with our K6 load testing. We have Docker Compose and Docker file. Exactly. So now, how are we gonna do it? So we are changing our rate limiting API to Snowflake auto-increment. It is not API, so it should pretty much work, I guess. Let's just replace it. I guess with regards of Docker files should be it. Let's also check it opens with Rider. So where is it? Where is it? Projects, distributed systems. Yeah, let me check that it can be opened with Rider. Because whenever you are moving your solution file here and there, it can cause a problem. So I will rerun it locally first, to just ensure it works, and then we will try with the Docker to narrow the area of the mistakes we can do. let me first, wait until it's loaded. Meanwhile, we can configure our Docker compose. In this case, we don't really need Redis as in our rate limiter, but we do need a load balancer, I guess. And for load balancer, there is an nginx config, which you also gonna copy paste. So what this thing configures, I'm not quite sure about whether it configures correctly or not. This I need to double check. But how it was working in rate limiter, there is container called API, which is our compute. And nginx config was just, yeah, I'm not quite sure how it should work. But Docker Compose was spinning bunch of such instances, so scale 5, number of replicas for scaling the service. I remember in the console I was seeing like 5 instances basically, so maybe it's gonna work. So this nginx is basically just load balancer. It will spread our load between the 5 containers in this case, but in our case I think we can maybe do just 2 for the demonstration purpose. So load balancer, we leaving about rate limiting. Basically, this is the configuration. We don't need it. We can just leave some, I don't know, some one value just to have it here. Docker file is okay. Rate limiter, no. It's snowflake. No rate limiter, we are snowflake now. Good, and Docker file should be done as well. Let me just rerun the service and ensure it works in the Swagger. Good, I see the Swagger loaded. Let me check. Yeah, it does generate the number. Yeah, it's monotonically increasing in the range of same machine. Machine ID, yeah, I remember what do we need. We need the machine ID as a configuration. So where is it? Yes, what we need here is machine ID, and machine ID is it numerical, right? It is numerical, so we are putting machine ID 1 so far. Good. These are also the limitation for our resource. I'm also not sure how it works. We will see together. But my intention and my idea that every single container should have exactly 1 vCPU, which is virtual CPU, and 2 GB of RAM. But RAM, we don't really care. We will not have big spike of RAM. I think mostly we are CPU intensive rather than memory intensive in this case. And this is our default port that we exposing. Actually, we should copy paste it from this guy. Yeah, this line. So default internal Docker port is exposed actually. When it was done. After build, okay. So after build, I'm putting it exactly here. Good. That's it. And now it's time for Docker. I'm spinning PowerShell. Of course, well, of course PowerShell. Maybe we can have one PowerShell for some statistics or whatever. And another PowerShell we can spin out of here just for the Docker thing. Okay, I was playing with Supabase and it seems like it didn't go properly and it wasn't clean up, so let me remove some bunch of containers. Yeah. I guess everything should be removed. One more. So we have clean workspace, you know. Docker system prune. Just, you know, to clean up every single stuff that was related to Docker. Yeah, I was playing with Supabase before. Now, since we are in our folder with Docker Compose, which is this guy, we can basically build our API. Let's maybe name it Snowflake API. So what we can do is Docker Compose up. Basically, it will spin also load balancer. Okay, let's create 2 instances. Yes, that's basically it. And therefore we're leaving only 2 instances here as well. API, backend, not API, but it should be the name of container since we are at the same network. I hope you know how the Docker network works. Whenever you have a Docker Compose, inside the same Docker Compose you have exactly same private Docker network, which means you can call your services mentioned in the Docker Compose by the name itself in the URL. It will be working. It's kind of internal Docker DNS. Yeah, let's try what will happen. Usually never just builds and runs successfully from the first try. Usually nothing, like it just does work like this. What about our Swagger? Is it alive? It is. It shouldn't be. Let's stop it. No, it's not. Okay, it is creating load balancer container. Oh yeah, I need to share some folder. And that's it. Seems like it runs. Now I think this guy we don't need anymore. What I want to do now is I need some ChatGPT basically to ask about a bunch of stuff. How to monitor CPU and memory usage of the Docker containers. I need CLI Docker stats exactly. This is why we spinned this guy, Docker stats. I want to see what is the memory consumption real time, right? I think it updates every half a second or something like that. So now let's see. We spinned our containers. Now we have one load balancer. Oh, I didn't want to do that. Yes, and it has memory limit 6 GB, which I think the limit of the Docker app on the machine, on my machine. And we spin 2 containers of our Snowflake AutoIncrement Scalable ID generator. They have this limit. And regarding the CPU, actually I don't see any limit for CPU, which is I don't know. Let me also ask about ChatGPT, because I never had this, you know, resource limits. So I have to ask why I don't see it and whether it is applied correctly. I'm running Docker stats, but I don't see what is the CPU limitation, how it works. Will CPU limit be applied to all instances, or it is for the service? Yeah, let's just ensure, like, because I'm not sure. Last time I was running load testing, as I remember, the CPU usage just went 100 and then that's it. Like whenever I was increasing the number of requests, they were served properly, so I'm not sure. You're using deploy resource limits and scale, which are only supported in Docker Swarm mode, not in regular Docker Compose app. Here we are. So this is actually ignored. Where scale 2 is not ignored actually. Scale 2 is not actually ignored. IC2 instances spam. Yeah, GPT is bullshitting as always. Yeah, wipe coders will replace us soon. Good luck. I can see it is happening right now, guys. Exactly, right now. Okay, so the problem, as I understand it, in my deploy YAML config, that it should not be in deploy or what? Docker Swarm, no. Docker Swarm mode is when you have different machines and you want to connect them within same Docker network. This is what Docker Swarm is used to. We don't need this, we have only one machine. No, this is bullshit. Okay, it is bullshitting, you know. It says that scale is completely ignored, but let me show you. Let me show you, guys. So we have 0 spawn scene. We are doing Docker Compose up. This guy creates one Snowflake API and second Snowflake API. So it bullshits me. This guy bullshits me. Oh my god. Yeah, wipe coders would like tomorrow. Tomorrow they are replacing us for sure, guys. Tomorrow. Let me try this thing as well. Let me just try this thing. So CPUs and this guy we just also how it worked. Depends on the Redis, but what the hell is this? Let's try. Okay, and limit also seems to be applied. Anyway, okay. Let me now maybe query this guy. How can I do it? How in my load test I was doing it? So it's 5,000. Yes, so we expose 5,000 port, which means that if we put this 5,000 port here and add our identifier route, this is post. I see the problem now. The problem is that I don't remember why it is post. Let me change it to get. I don't really remember the reasoning behind it. Let's just put get endpoint and rebuild it completely. It's interesting, while I was solving LeetCode, there was like maybe 2 guys watching the stream, and right now we have 9 people watching us, and it's kind of cool. It's cool, especially having in mind that only 3 of them from YouTube, and I don't know, this is bullshit. Numbers are not accurate, it seems like. I see 2 people in the Twitch and 3 people. Yeah, but it shows 7. Okay, whatever. So it should work at the moment. Yes, yes. So now our get response will be giving us exactly the identifier. Now what we want to do is okay, this is interesting how we're gonna implement it. So now we should maybe create, okay, I will be, yeah, maybe let's do it next time. Can this guy give me a quick solution for the Redis? Because I want to demonstrate that uniqueness is actually working. How can I do it? I think through the Redis I can do it pretty easily. So let me ask GPT again. It will bullshit me maybe, but this is my case 6 load test. I want to write response from the service to the Redis. Can you do it using JS? I'm okay with it cannot write directly because it's client. Yeah, basically we can't do it, unfortunately. Unfortunately, we cannot do it. What are other options is to, for example, what we can do is we can implement basically Redis client over here. We can set up our client in our Docker Compose, and then after that our identifier will be in parallel written to the Redis as well. Basically, this can be the solution, this can be the solution, I guess. Again, I don't want to waste time over it, so please implement a Redis client that will connect to, and let's specifically actually have already Docker Compose for Redis, right? For Redis, we don't need any memory boundaries, so just let's drop this completely. And this is Snowflake network, not rate limiting network anymore. Yes, and how was it implemented in rate limiter exactly? It should be Redis sour. Yeah, and yeah. Okay, it should write identifier, our unique identifier to the Redis, and increment the number of times the identifier was written. AJ. It does not exist at first, then 111 is written, it becomes this guy, 111 equals 1 time, then if it is written again, it should be, I hope this guy will implement it for me. What I actually want, I want atomic auto increment, so we don't lose anything. And also what I want to see the all keys and all the results. This will be the problem. Okay, so I need to install this package, of course. NuGet. Forgot how to do it. Install, yes, exactly. Install, please. Now we also need to connect it. Sorry. Will it be able to resolve? Yeah, it will. Now we have connected client, and what we do, we just replacing our. Was it completely useless? So now how it looks like. Instead of our unique number generator, we also added the Redis logic, or not we, this guy. We don't really care about it, because this is only for demo purposes, right? To show that it really works, right? So what I will do, I will put it inside the Lambda for a task run, which will basically spin a new thread in parallel that will do this thing. Exactly. Oh, I don't think it was the... Yeah, I think we were returning something else. Yes, and I were right. What we were returning is this guy. Oh no. Yeah, we're returning just identifier, plain text. Exactly, we don't care about it. Let's put comment. Later on, when we will be implementing URL shortener, and we're gonna use this service, we will remove this stuff completely. And this is just for you know, for correctness proof. Please add additional get method that will, for example, show all the keys that have more than one counter. Good. Hello, X Rutska. I'm sorry, I'm very bad with pronouncing of the nicknames, but hi, hello. For all the new people, we are implementing system design that we have designed previous stream for the scalable auto-increment unique number generator, which is partially monotonic. I mean, it is monotonic. No, it's partially monotonic. Yes, it's partially. We are using Snowflake ID algo for this. And now we are writing load tests that will confirm that it actually works. More specifically, right now I'm implementing the workaround over the Redis that will actually prove that all the numbers that we have generated are really unique. This is exactly what we're gonna do. Yes, keys, we are iterating. This is just a snapshot. We're gonna show all the rows that have number of times written more than one. And for the first case, to validate it will work, what we're gonna do is we're gonna comment this line completely and instead put, I don't know, 1. What awaited? Yeah, it is intentionally not awaited. We don't want to stop and to, you know, to burden our latency by writing to Redis. This is not intended. We're gonna remove it. Now what we're gonna do, let's rebuild our solution, verify it works. This is identifier endpoint, but we have another endpoint that we just added. It is called blah blah blah. This is poorly GPT generated. I don't really care about this endpoint, it's throwaway work anyway, right? So AI is kinda useful at the moment. It is just okay. It's not English X, it is Russian X. Ah, okay. Khruchka, okay. Most probably. I see. Yeah, okay. Makes sense. So does it work? Okay, 500, so we got some. It was not possible to connect to the Redis server. Okay, now let's see the problem. Oh, it's the close array limiter. Well, did we add the Redis? No, we didn't. Oh, what the hell? Ah, yeah, because I didn't save, sorry. We didn't spawn the Redis container. Now let's see. Good. Well, what? Additional public Redis is not allowed. What do you mean? Ah, yeah. I understand. I understand now. What are you doing? So we are developing Snowflake auto-increment solution. The solution for generating unique Snowflake for generating unique identifiers, ID generator. This guy. This is the system design for unique ID generation in a large scale in distributed system. This is basically the solution that you would need if your single machine, I don't know, Redis or database cannot handle all the requests for auto-increment ID. Basically, the idea is the same as UUID version 1, which you just have 64 bits. And you put timestamp, machine ID, and sequence number over it, and it kind of guarantees you the uniqueness. You don't use any additional storages and stuff like that. This solution already is used in Twitter, Discord, and Instagram, so in some of the versions. So this is basically it. Hello, one more time. Have you ever used it in a real project? No. Personally, my project that I'm working right now at Microsoft, it is highly scalable distributed thing, but we don't need auto-incrementing IDs. But this approach was used in real production by these guys. The names that you most probably have seen already somewhere. Good. Okay. It is kind of working. Not really. Okay, why it doesn't work now? Where is 500? Well, this is pretty interesting. I don't really understand what's the problem. Identifier, right? Okay, now it works. And this guy works. Okay. Yes, so here we are generating our sequence numbers. I think I put seconds precision, so we for sure need to get, yes. So this is the proof that in case we have more than one identifier addition, we will see it printed from our Redis snapshot. Let's now fix it back. So for now we were doing like just writing one. At the moment we're gonna write just the key. And yeah, we can do it even with second precision. Actually, this guy would do total seconds instead of milliseconds, so that we can prove that our sequence number approach works, because whenever on the same machine we are receiving requests the same second in this case, if we have two requests at the same second, we're gonna generate exactly the same IDs, which is not acceptable. So instead of this, we have sequence number, and this sequence number is atomically and monotonically growing. Every single request will have a unique sequence number. This is the idea, basically. So let's see how it works. Yeah, let's just build it up again. Since our red is, I don't know whether it preserves data or not, but most probably we're gonna see again this identifier after it sets up. No, it erased all data. Anyway. Okay, so if I generate very quickly. Okay, seems like it doesn't work. It wrote exactly 2 times. Which is interesting. Let me find out. Actually, we have it in our logs. It has been written 2 times. Milliseconds. So let me analyze the logs. Okay, first one and second time. Seems like sequence number doesn't work really, which is interesting. Why? So we have let me check. So we are getting second and millisecond exactly, and for millisecond get sequence number. Okay, interesting. Is it in thread safe manner? So sequence number is our concurrent dictionary, so basically it should work. Okay, I'm actually wondering what will happen if we add more load tests. For that we need one more terminal exactly, and we snowflake. What is the way to run it? But before that, let me put, I don't know, so far I want, let's say for 10 seconds, I want 100 requests per second. Let's run it. But why it doesn't work for concurrency? Maybe this thing should be... Okay, interesting. Let's see what load testing will give us. Okay, all requests. Sorry. It was going to rate limiting. Come on. Instead of that, we want it to go identifier. Let's do it again. Okay, everything is successful. We should have seen, yes, our logs. Good. Let's check also the Redis right now. So mostly I see it only count equals 2. So I would actually assume, is that maybe the initial creation of this guy is not that safe. Let's actually ask in GPT what I'm thinking. If 2 concurrent requests gets to this point, well, it still should work, right? But yeah. Let's check logs again. Okay, let me just check what is the problem, how we can do it. The easiest way to do it is to just create some log object, and basically in the end, let's check whether the problem with the log, so the concurrency is here, or there is problem somewhere else. Now it's completely serialized in the way of the order, so it should be actually working. Oh shit! Yeah, it's correct. Let's check. Let's see. It should be actually working. Why didn't our Redis cleaned up? I don't like it. Redis should be clean. Completely, let's kill the Redis. And now it doesn't exist. And let's rebuild. Yeah, they are duplicated somehow, but I don't know how. They should not be actually. They should not be. What is our snapshot doing? Maybe the problem is snapshot. So we are iterating over all the keys. If we parse and count more than one, yeah, then we yes, works. Should be working expected. Let's see. Yeah, our Redis is empty right now. Let's just very quickly spawn them. No. It actually does not work that way. It means that the problem is not in this specific sequence number. Yeah. Some logs, yeah, exactly. This is what I'm looking at right now. Okay. You know what we can see? I think we can come up with a bit better observability at the moment. So what we can do now? Yeah, we have some race conditions for sure. For sure we have some race conditions. So what I'm gonna add here, I'm gonna also add identifier itself. This is first thing. Second thing, instead of identifier, what I would like to write then is the exactly part by part. So milliseconds plus machine ID plus sequence number. This way I think we can see where is the problem exactly. And also will it be enough? Yeah, should be. Same way we can do, I think, here. For easier searching in the logs. It's actually machine ID. Yes, let's again restart. Killing aware this again. Let's see what is the problem with our concurrency. But good part that it seems like it's not related to this part of code, because if we have to, like, yeah, using this log is very bad approach. Very bad approach for just incrementing the number. Like, this is heavy synchronization practice. Better to use interlocked. Okay, it's set it up. Redis is empty. Good. Let's generate some numbers. Let's see now. Okay. Okay, these are the number of seconds, right? And I also wondering why only 2. This is what, like, interesting for me, because it shouldn't be 2, right? If we have some problem with them, definite problem with race condition, it should be more than 2. We should have written much more same sequence numbers. For example, we wrote like a lot. As you can see, a lot. And sequence number in general works, but count is only 2. So I would say there is some problem with creation maybe of this stuff, I don't know. But now we're getting milliseconds, they're the same. Interesting. Okay, let's just no results. Wait. Okay, we found something. Yes, this is for next time. Okay, so interesting. Ah, okay, so I can see. You see that sequence number is pretty much increasing all the time, and the problem is not on the beginning. The problem is in like on the last stage, right? Even not the last before the last. Somehow it generated same sequence number. Now it's very interesting how is it happening, because right now I don't see it should happen at all. Ah shit, I think we are just shifting the not right number. No. This is an interesting problem. I think we don't really have time to debug it more. What I would ask maybe is I would just hand over it to Claude or something like that. Because I think it might maybe hint us to something. There are some sense that let's I'm really curious how is that possible. I'm stupid as, oh my god. You know what? The problem is actually easy. We just spawned 2 Snowflake servers with the same machine ID. And this is exactly the problem of having machine ID as part of your deployment, right? Oh my god, I'm stupid as table. Now it will work 100%. Now it will work 100%. Yeah, each instance should have actually different ID. I don't even think we need to have lock-in at the moment. Yes, this is very good catch by Claude. Well, yeah, sometimes you need to debug it for a long time to get it done. It's okay. It's okay. Yeah, now let's see. So, is it empty? Yes, it is. Let's just generate a bunch of. Great success. Now we are running our load test for 100 requests per second for 10 seconds. We should be around 1000, right? No, actually more than less than 1000. Let's now check. Exactly empty. Now let's increase a bit to 1000, right? And then go back to 100. Meanwhile, monitoring our Snowflake CPU and memory. I'm starting. This is now 1000 requests per second for one instance that has 2 GB RAM. And I don't know whether it works. It's not shown here, but I assume it has 1 vCPU. But let's check it actually. I will run this guy to check about CPU usage. Maybe we can come up with something here. Where's the CPU? Okay, CPU 6 cores, but can I see statistics per core, please? Oh my god. I remember in older Windows you could see, you know, per core load. Now it seems it's not the case anymore, right? Ah, okay. I'm sorry. Let's check per logical processor. So I'm starting the load test. 1000. Let's go. And let's monitor our performance meanwhile. So we can see that CPU is 24% right now at the moment. 37. Okay. 100%. Okay, it should start throttling, to be honest. It's 130 CPU, 150, 160. It is 1000, 150. So yeah, and it decreased. So on the peak it had 150 CPU. I don't really remember what was the memory, but I don't think memory is the problem in our case. Yeah, one thing what we should do. Actually, there is memory leak for the guys with the high degree of attention. There is a memory leak in this piece of code. Can you find it? By the way, we should also check correctness. Oh yeah, it's it is stuck because we have a lot of keys in the Redis that we are iterating over, but we don't have any key that was inserted more than once. And we have second precision. It means our sequence number actually works. About the memory leak, I need to solve this problem later, but long-term solution, it will not work. Solve memory leak. Older milliseconds are not erased. So our time is constantly growing, and we are inserting sequence number per millisecond, so it means we have constantly growing milliseconds, and it means we're gonna add to this sequence numbers dictionary constantly growing numbers, and we never remove them. So in the end, we will have always growing number of records in this dictionary, which is the memory leak. But we kind of know about it. I will try to come up with some solution how we can basically remove periodically this dictionary, because we don't need to store previous millisecond. Basically, we don't have to store it. There is no any purpose for this. But algo seems to work correctly, and based on our benchmark, basically no request was throttled. But based on our benchmark, with memory limit 2 gigabytes and SWE CPUs counted by 1, yeah, we see that our CPU usage grow to 150, which means we need at least 2 vCPUs per 1000 requests per second. So, you know, the math behind that is if one CPU can handle 150%, so it is loaded on 150, twice as much should have 150 divided by 2 equals 75%. So we have 2 vCPUs, we should see 75% of load. But since I don't really know how I can pass different configs per 2 instance, per one of 2 instances, let me just check the last thing like this, and if not, we are finishing. Yeah, in this Docker compose, how can I pass different env config machine ID per scale instance container replica? Maybe we cannot do it, even that is possible. Yeah, I cannot directly set blah blah. When you use scale to, all instances receive the same environment variables. Here are a few approaches. Docker swarm. Thank you very much. Docker swarm. I don't like the approach. I'm sorry. Separate service definition. This is the case. This is most probably how we're gonna do it. Yeah, so let's spawn 2 different guys instead of 1. Exactly, scale we are leaving 1. This is gonna be second machine ID. And we should update our Nginx config. Now it's API 1 and API 2. Exactly right. I just want to see that I'm correct with my computations about CPU load. Yeah, very good, very good. I like this load testing. I like that it proves the correctness. Well, if this algo is used in Instagram and Discord, most probably it's proven that it's correct. Great success. Okay, this one is not expected. Host is not found. I see the problem. Ah shit, what did I open? Wrong Nginx configuration, of course. Wait, what happened? What happened while? No, please do a new instance. Ah, okay, it was loading for a long time, I see. Yeah, also what we should do, we should kill actually Redis because it takes time. Docker ps all, docker remove -f. Let's recreate Redis completely from the scratch because it has a lot of data and it will take a lot of time to load a snapshot, right? Yeah, now it's much faster. We can generate identifiers. We have different machine IDs, and now let's run our load test for 1000 requests per second. Good, exactly. Oh shit. Yes. Boom, boom, boom. So, yeah, it seems it's growing pretty simultaneously, which is good. Seems like engine's doing good job. So they have 100 loaded each. 80. Yeah, so at peaks it was 100. So it seems like 1000 requests per second. You need 2 instances of one vCPU. Basically, this is the mass. So now, people, I think we are done. Unfortunately, we are not doing real interview questions like these guys. We are leaving it for the next time. Yes, for those who would like to find the repositories with the Snowflake implementation, please, I'm leaving you the link in the description to the GitHub repo. It's completely public. Also, please don't forget to subscribe to my social media, especially Telegram, because we are doing polling. We are talking about Microsoft, software engineering live, about Office, Corpo, all this stuff. You might be interested. Also, what is more even important for you, we are talking about what will be the next. That's it. Which questions were answered already? Well, I think most of them I have answered somewhere in my notes, but we are going it straight away from the scratch. I'm just showing how would I approach it to get some real good offers and positions. Because this is how in 2 years I got senior title at EPAM. I just knew all of these questions and answers to them. That's it. Nothing actually special. But at big tech companies, it doesn't work, and you don't really need it. For big tech companies, you need LeetCode and system design, which we are actually doing right now as well on the streams. Okay, so far it's all. I think I'm committing my changes to the repo, and I think we should finish right now. I'm hungry. Streamer is hungry. Streamer is tired. Thank you for watching. Thank you for attending the stream. Let's see. Yeah, see you next time, guys. Don't forget to subscribe. Next Sunday, we are here again. Again, thank you for being with me. Bye.